Hello everyone, this is Ajay and my teammates are Mannan and Shashwat. Here we are presenting KMST course project and our project title is Movie Link Data Publication. So in this project, we are addressing the problem related to movies. So there are multiple platforms provide access to movie related data, but this is information is frequently unstructured and unconnected, making it difficult to search and analyze effectively. In this project, we intend to develop a structured ontology of movie data capable of linking information from the IMDb movie database. The ontology will provide a standard vocabulary and a framework for integrating movie-related information, thereby making it simpler to search and discover and analyze the data. In order to accomplish this, we have extracted data from IMDb, mapped it to ontology, and linked it to in order to facilitate the effective search, discovery, and analysis of movie-related information. A website has also developed that user link data to allow user to search for movie based on various criteria and analyze movie rating, demonstrating ontology's effectiveness in facilitating the search and discovery of the films. So in this project, we have these objectives. The first one is to develop an ontology that specifies the standard vocabulary and data representation structure of movie related information. The second objective is extracting the data from IMDb movie database and map it to the ontology. And the third objective of this project is the using this ontology connect the extracted data to facilitate the effective search, discovery, and analysis of movie-related information. And the fourth one is to develop a website and the website that uses link data to allow user to search movies based on variety criteria and analyze movies rating, demonstrate how the ontology can facilitate the effective search and discovery of films. The next part, ontology and methodology, will be presented by my friend Sas.
So here, if you have a look at our protege window, so you could see that we have defined various type of classes such as country, genre, language, person, title. So whatever a movie, whatever classes a movie required, whatever data objects these movie class have, we on the basis of it we started defining our ontology. So movie has actor, composer, director, writer, country, genre, language, these kind of things. So we define these kind of classes. So in total, we have 12 classes and 17 object properties. So here, if we look at object property, we have from country, from studio, has actor. So if you look at the next here, you could see that the ontology graph of our ontology graph. So you could see that title is related to writer by property has writer, and has writer that means that title has writer, and it is inverse or just is writer of. So you could see here that the person is a super class of actor, writer, director, and the country, genre, studio, and these are different classes. So this in total defined our ontology of our movie database. On the second, if we look at it data properties, we could see that title has rating IMDb as decimals, and website as string, runtime as int, premiere year as int, and person has birth year, death year, sex as string, and different kind of things. So this was the definition of ontology. We defined ontology on the basis of the requirements we needed, and with the help of the paper in the references given by Avancha et al. For the design of ontology for IMDb. So here this was an ontology. So now we have designed ontology. What comes next? So next comes the methodology, like how we proceeded with our project. So first part was the data collection. So our data was collected from the IMDb website in the zip format. So here, if you look at this website, here we could see that IMDb has provided some of the zip files such as title.aks zip, which contains title, ordering, region, language of the movies, such and other things such as title.q, which contain director and writer of for a given title, and the name of the actors, director, and their birth year. So these information, these zip files were downloaded into the local machine, and then and then they were then further given to the data extraction process. So now comes the data extraction process. So the data extraction process included converting these TSP file first into a JSON format, and then these JSON format to their corresponding RDF format. So these TSP file were converted into JSON. If we look at a GitHub repository, so we could see that in a linked movie representation, repo, if we go to IMDb data folder, here we could see that we have mentioned the script.py. This script.py extracts the data from IMDb database to a JSON format. So here we could see that this is reading the title rating, title basic, these kind of zip files, and here we are filtering out some of the movies whose number of votes are less than 10,000, as because we can't handle all the movies and all the data in a data set. So just to filter out just to filter out these skewed movies, we filter them out, and we also filter out the rows which were having some of the elements as empty. So after this filtering, we generated a JSON file which is then here given in IMDb folder as movies.json and humans.json. So now our JSON file has been created. After that, we now need to convert it into RDF format. So how we will convert it into RDF format? So what we did is we first designed our ontology in Protege, and we manually entered some of the individuals in the Protege file. Here you could see here you could see we manually entered some of the individuals, and then we printed the ontology file of in the RDF format. We then analyzed its RDF format, and we found that we found that there is some connection between these. So if we look at auxiliary folder, we have mentioned our JSON to RDF script. We use this script to convert our JSON file to RDF file. So here, if you look at a function, so here prepare human RDF is for a person is for an individual to create a person class. So now everything related to person is taken, such as its ID, its type, its profession, its birth year, death year. Everything is included in a string, and that string is then sent to a final RDF file. So that string is printed. So with through this we generated a RDF file format into Turtle. Now then comes the data representation format. The Turtle file was then hosted in Apache Fuziki server, and that with the help of Node.js and the front-end code, we use the data representation. The further demo will be explained by my friend Ajay.
So after use this turtle file, we can run the Sparkle server, and for the Sparkle server, we use Apache Fujoki server. So let me run this server. So here we are opening the command prompt, and using this command, I'm going to run this our Fujoki server. So as you can see, our server is running on port 330 localhost. So I am going to browser opening localhost 330. So as you can see, our backend Sparkle server is running on localhost 330, and we have already created one KMST dataset. Here we have uploaded that turtle.tdl file. So now we can run our front end, and for front end, we can run this by using npm start. And after running it, our front end is running on localhost 3000. So as you can see, our front end is running on localhost 3000. So we can query with the Sparkle query, and there are some options from we can query with the help of these options. So we have made one example query where we want to show the names and total box office earnings of top 20 movies and sort the result by descending box office earnings. So let me copy this and paste it in this. see, our Sparkle server is running on 330, and the node server is running on localhost 3000. So this is our Sparkle server. Here we can run one query, and as we can see, we will get 5 results. If we change it to 10, we will get 10 movies, and the corresponding natural queries is the show the names and the total box office earning of top 20 movies and sort the result by descending box office earning. So I'm checking for 20, and if we run this, we are getting 20 movies. As you can see now, we are run this query on our front end as well. This is our query, and if we submit it on, then we are getting the 20 results. So now another option in our project is we can search any movie by their name. If we search like holiday and it enter, so we are getting the information about that movie, like plot, years, director, writers, actors, studio, rate, genre, language, production location, number of votes, rate IMD, and all others. And we can also search any person with name. Let me search Robert Downey Jr. and hit enter. Then we can see it's giving our birth year, sex, and known for the movies in which this actor has has worked. So these are dynamics. If we click on these Avengers, then it will give the movies information. And for this in Sparkle, this file we have made endpoint where we are hitting when we press submit button, we are hitting this endpoint. So first, like suppose uh, someone go on a workbench. Let me show. Like in this, we are in as we can see, this is local 1000 title and the ID. If we are in this, then we are getting this route. So we are getting this title and ID, and based on this, first it is querying on our Sparkle database and getting the URI, and based on that URI, it is getting all the information and then we are passing these details. So the individuals can be dynamically. Let me show how this like see the writers. It is dynamic. When we click on this, we will get all the information about Jack Penn. So this is all about this project. There are future scope. We can add more option in this project. Like we can search all the movie by all the genres and or many more things. So that's all. Thank you, everyone.